My name's Tony Moore-Crone. I'm a technical marketing engineer. I've been with Cisco for over 20 years and about 12 years in the BU, so kind of looking at SIP, Session Manager, IPv6, security. There's a lot to cover here in the slides, and I've been reworking the slides pretty much every year. So first of all, one thing is I made some changes last night. So if you go to the team space, so BRKUCC-2006, you'll find a PDF version of those slides. There's not really much in the way of additional information that I made changes to last night. It's really just some reordering of the slide, adding some information back in. So you can pull those down from the space itself, and they will be uploaded to the regular portal as well. In the slides themselves, we've got maybe 150 slides of content to go through. There's probably an additional 140 slides in the appendix. So the purpose of this session originally was to address the kind of issues on SIP trunks in Call Manager, that if you went to the help page, or you looked at a feature, insert SDP, for example, or insert MTP, and you clicked on the help value, it would just repeat what it actually said, the description. And one of the main things that I wanted to do here was to try and address some of that. So there's a lot of detail in there, but I've really pushed a lot of that into the appendix. And through several iterations of this, I've tried to kind of hone it down to the main pieces. In terms of housekeeping, so feedback is really important. One of the things that you may become aware of is that I speak quite quickly. If I'm speaking too quickly for you, or I'm not speaking clearly enough, I want you to raise your hand and let me know, because the worst thing for me is to get marked down because I've been speaking too quickly and nobody's called it out. Other than that, switch your mobile phones off, follow the other regular stuff. In terms of the agenda, what we're going to cover off here is really a wide range of stuff. So, there is a SIP 101, we do the SIP basics there, so not everybody in this room is going to be aware of SIP basics, so we do the introduction to that. We'll look at SDP, so how you negotiate media, and then we'll start drilling down a bit. We'll look at some essential SIP trunks. Again, there are hidden slides, there's more at the back. We'll look at feature invocation. Again, I've cut that down, so I'm really just looking at the make, break, how that works over SIP trunks. And then the last bit here is really looking at large-scale design. So it's really trying to put all of this together. So we're looking at multiple aspects. We'll look at dial plan, call admission control. But what I'll try and draw out as I go through is, if you're looking at SIP trunking, what are the essential rules that you need to look at when you're putting large-scale designs together? So for SME designs, I probably do 1 or 2 SME design reviews a week. And what I send out to the people within Cisco who are doing the reviews and the partners is essentially a stock presentation to say, okay, here's a sanity check. Are you doing all of these things on the SIP trunk? So we check that they've got everything right on the SIP trunk, so they're doing the right things, and if they're not doing those things, why are they doing things differently? We'll check dial plan, we'll check call admission control, we'll check how they're using media resources. So that's the main thing to take away beyond the kind of the basic stuff, how SIP works, and reflecting how some of the things you'll see in headers, how those change as you change the configuration in Call Manager. The main takeaway here is that if you were going to design a system with multiple call controls in it, what are the key takeaways? What should you always be switching on, and why you should be doing that, okay? And then, as I said in the appendix, there's stacks of additional stuff, so use it as reference material. I have gone through and tried to basically give a description of each of the features on the SIP trunks that are important and explain why they're used. What you'll find on the SIP trunks, by the way, is a whole bunch of features that you will never use that we develop for service providers, for example. You'll probably never need to use them, but the main ones are there for you, okay? This is the space, so if you go to Cisco Live and go to this and join this space here, we can follow up with questions afterwards, but about an hour ago, I posted in a PDF version of this deck. So if you've loaded anything before, it's pretty much the same, but I've just reordered stuff and changed stuff around, okay? With regard to questions, please raise your hand at any point. I've kind of got timing on this. I should know where I should be about an hour in, and if we're getting too many questions, I might kind of pull them to the end, and we can ask them afterwards. But if it's interactive, it's better for everybody. And I know it's like the morning after the big party, so I'll be keeping my eyes open to see if anybody's nodding off while I'm presenting. Okay. So The first one here is, here's the agenda, what are we going to be looking at? And the first one here is like, why choose SIP trunking? The primary reason is just that it's become the de facto standard. And I'll talk about cloud and some other pieces as well, but really today, if you're looking at any vendor, certainly for on-prem and certainly if you want to do interop, what they're putting their development dollars into is into SIP. That's really what they're doing. If you look at MGCP and H323, certainly on the call manager side, on all of our collab products, we're not really spending a lot of money on H323 or MGCP. A question I ask every year is, how many of you are using MGCP trunks and gateways out there today? Okay, so it's still, the thing is, I think it's been consistent. It's gone down slightly, but it's been consistent pretty much every year. MGCP is still out there, and it's still going to be out there. And the main reason that I think it's there is because it's easy to configure. So there's very little to configure on the gateway. You backhaul everything to Call Manager, and you provide the configuration in Call Manager. And I think that's the primary reason. But we'll take a look through that, and we'll compare the feature sets. I have no issue with you running MGCP gateways off Call Manager, for example. So if you've got a Call Manager down here, you've got gateways to the PSTN, running MGCP is fine. But if you're connecting multiple Call Managers, for example, or a voicemail system or a conferencing system, what I suggest that you do for that kind of interconnected network on-premise, for example, is that you do use SIP. If you do use SIP, it just makes it a lot easier to design and to troubleshoot your network. So again, if you look at interoperability, if it is all SIP, it generally works. So we're kind of past the days, 7 years ago, 8 years ago, when you'd connect to a Nortel CS1000 and various things wouldn't work, options ping wouldn't work in the right way. Most vendors have kind of ironed out the major issues here. And if you look at the SIP trunk, then in most cases, you plug it in, configure it up, and it should work. There are still differences, and there are tools that you can use in Communications Manager and Session Manager to address those. Things like Lua scripts, for example, for slight variances. Likewise, in Cube, you can also tweak the configuration to address interoperability issues. But if you do have multi-protocols, so let's say you had multiple systems connecting via H323, MGCP, and SIP, then debugging that really gets complex, because not only are you looking at how the standard works for H323 or how it works over MGCP or Q931, but you're also looking at the specific configuration. Is it fast start or slow start with H323? What are the configurations on the trunks? And it really makes it complex. If you're running SIP everywhere, then you can essentially kind of go through a mind map. You can kind of visualize in your mind how the call's going to be set up from one trunk through an SME to another call manager and out to an application, for example. And you can kind of work out, okay, I won't be inserting media resources here. Here's what I'm expecting to get for DTMF. You should be able to do all of that. And today with SIP trunks and with the endpoints that we have, things like transcoders or MTPs for DTMF conversion, you generally shouldn't need them. If you design it correctly, you don't need them. But we'll go through that as we go through. So, why recommend SIP trunk? Well, again, as I said, we've been putting our dollars into this, and it's really since 7.1 that we start to see that kind of divergence away from H323, which kind of was the norm for everybody was using gatekeepers, for example, for H323, but we start to see this growth in SIP. And likewise, you see this development in terms of the features that we're supporting here. So IPv6, can I get a show? Who's using IPv6? Okay. So we're seeing, again, it's been a slow growth with IPv6, but if you want to use IPv6, you're going to be using SIP trunks. We simplified call routing in about 8.5. That really came about with the introduction of Session Manager Edition, which was introduced about 7. It was actually 6.1.3 that we did our first implementation of that. But we kind of realized that the way that that you could configure trunks with call manager groups really didn't work very well in an environment for Session Manager. And so we introduced things like run on all nodes, multiple destination addresses to try and improve the way that you could configure the trunks themselves, but also the way that calls routed through call manager clusters and through Session Manager clusters. And then SME clusters, so really from 8.5 on, so if you've got Session Manager today, you should be able to build that without any media resources. So if you're making a call from one system to another, you should never need to invoke a transcoder on the SME cluster. You should never need to invoke an MTP to do some DTMF conversion in the SME cluster. And what you're doing is keeping your media local between the two phones that are making a call, or directly between the two phones that are making a call without hairpinning. Lua scripts are still used today, so we see it mostly in the service provider space. If there are slight differences, they're very powerful. I'll take you through a slide on that, and there's a reference to a white paper there as well. We'll go through codec preference lists, codec pass-through. In 9.0 and beyond is really ILS and GDPR. So if you're not familiar with ILS and GDPR, there are a few slides on that. But it's really a way to simplify the way that you're sharing information about numbers and URIs between multiple systems. So it's supported by Call Manager. It's also supported by Cube, Session Manager. But if you had, let's say, a Microsoft system and a VIA system, you can import URIs and numbers in that system as well. But today, what I see, particularly with multi-cluster designs, that GDPR is pretty much the de facto that people are using, because it greatly simplifies the way that you set up your call routing between the clusters themselves. And the last one here, the last key one here, is best effort early offer. So before best effort early offer, and actually from the very beginning, one of the main considerations that you were thinking about when you were connecting SIP trunks between one system and another, or between like systems, is whether you're doing delayed offer or early offer. With best effort early offer, it certainly simplifies things for you, and that's what the recommendation is. Again, if you start having one trunk that's doing delayed offer, another doing early offer, you run the risk of inserting media resources, and I'll go through and emphasize that fact as we go through. But the first thing is, let's look at H323 trunks and SIP trunks on Call Manager and compare those. So just as an eye chart here, you can see that there's a lot more red for H323. So again, SIP is much more feature-rich. In terms of authentication and encryption, we're using TLS rather than IPsec, so it's much easier to set up. The yellow features here, so run all nodes up to 16 addresses, for example, those are features that are there on H323 and SIP trunks, but things like options ping, just tracking the reachability of the far end, is SIP only. If you're doing an SME design, you're clustering that SME cluster by placing nodes in data centers globally as a single cluster, you can only do that if you're using SIP trunks. So there are lots of reasons why it's worthwhile going down the SIP route. And in fact, most customers today, I would say that they don't use H323 intercluster trunks. Actually, can I get a show of hands? Who's using H323 intercluster trunks today? One or two, okay. Yeah. So most people are moving to SIP. I'd say about 3 years ago, I saw kind of regular migrations from gatekeepers to SME. It's not rare today, but it's not as often. So we're seeing that kind of infrastructure of gatekeepers and H323 trunks migrating across to SIP over time. So these are for intercluster trunks. If you're connecting to gateways, then again, you'll see some differences here. So you'll see the main difference up here for MGCP is that those first two things, centralized provisioning and centralized call detail records. What you're essentially doing with MGCP is that you're taking the D channel, if it's Q931, and you're basically just backhauling that all the way to Call Manager. So all the call control is really done in the Call Manager itself. If you're running H323 or SIP, you'll take that D channel, you'll terminate it in the gateway, and then you'll re-originate new signaling from the gateway up. So there's configuration work to be done if you're using a H323 gateway or a SIP gateway, but again, with a SIP gateway, what you get are more features there. Again, what you'll see here is that things like run on all nodes and up to 16 destination addresses is there for SIP gateways, but not for H323 or MGCP. And that was really my fault when I asked the development team, I said, can we do run on all nodes and multiple destination addresses for trunks? That's exactly what they did. And a SIP trunk between two clusters, you use a SIP trunk, but a SIP trunk to a gateway is a SIP trunk. But if you want to configure a H323 trunk to a gateway or an MGCP trunk to a gateway, that's a gateway configuration. So they omitted doing these features on the gateways here. So there are some gaps. But again, if you're looking at this, then again, SIP is the way to go. It really is. You get far more features, and it tends to be the kind of lingua franca. Everybody kind of that I talk to these days, I rarely talk about H323 or MGCP with customers on a weekly basis. Okay, so I've got 5 or 6 slides here to go through the basics. So some of you may be familiar with the basics of SIP already. Just bear with me because there are people in the room that don't understand it. And it's just a general concept as to what SIP is. There's some very basic stuff here, but it's worthwhile going over the basics. So the first one is, what is SIP? So Session Initiation Protocol. Jonathan Rosenberg, who used to be at Cisco, was one of the guys who kind of came up with SIP. It was originally created for gaming, but it took off in the collaboration space. If you're going to read RFCs, this is one of the RFCs that you want to read, RFC 3261. And it is worth reading it. If you want to know SIP, it's worth reading it, but look at traces and try and get an idea of how those features in the RFC are being used in the environment that you've got. But the things that they'll talk about here are user agents. So SIP is a request and response language, and there is a user agent client which sends requests, and the user agent server which receives requests and returns responses. A phone is a combination of these two things, so both the client and the server here. So I'm going to send an invitation to participate in a session to the far end, and this guy's going to respond back with multiple messages, but it'll either be an okay, let's go ahead and do it, I've moved, I'm busy, or so on, okay? If you look at the request types, there are multiples of them. They're well defined, but the key ones here are invites. This is the one that we're going to look at in most detail. So this is the request to invite somebody to participate in a call session for you. So it's going to be a voice call, a voice and video call, for example. You'll see the ACK in every transaction that you make, or you should see it if you have a successful transaction. So when you send responses, you want to acknowledge that the signaling for the call has been correctly set up, and you'll see the ACK to come through to say, yep, we've got the final response to the invite, and we can go ahead. Again, the ACK here is often used by service providers to bill. So when you send that ACK, at that point, they're going to start billing you per second for a call, for example. Bye is pretty straightforward. It basically terminates a call that's been set up. You have media established between the two devices. It will tear it down. Cancel is, I'm ringing you, you're not answering. I'm going to put the handset down. It will cancel the call. Options. So it was really originally there to query the capabilities of the far end, what it supported in terms of methods, but it quickly became a method whereby what you're doing is you're just sending this options message out. You get a 200 OK back to say, yep, I'm still alive. And so today, options is widely used as a keep alive mechanism. Register is not used on trunks. So register is only used by phones on Call Manager. And so when the phone comes up, it will send a register message. It will register its IP address with the Call Manager. On the trunk, when you think about it, I could have 10,000 phones behind Call Manager here, a trunk going out to the PSDN, or going to a SIP proxy, for example, I'm not going to send registration messages over that trunk. One, you'll be sending thousands of them, and there's really no point. We have the concept and the model of having route patterns on both end systems to say this represents not individual numbers, but 1XX represents 1,000 numbers here, and to get to this range, just point to this trunk or go to this destination. PRAC is something that's kind of recommended today across everything. It's called provisional acknowledgement. We'll delve into that in more detail. It's generally recommended that you would switch it on anyway, and I'll tell you why that is, but it's in situations for where you have long round-trip delays. But even on a short round-trip delay, there are good reasons to switch on PRAC. Subscribe, notify, publish is for presence information or KPML. So KPML is keypad markup language for DTMF, for example. And then there's other messages here, so it's update, message, and refer. So you send your request out, you'll send your invite out, the first message that you send back, and then you'll get a series of responses back. So those responses are based on HTTP, and they're kind of categorized into provisional responses. Those are 1XX responses, success, a 200 OK, for example, the 3XX for moved or busy, for example, a client error, server error, and a global failure. So some of these you're going to see. So 100 trying and ringing we'll talk about. We'll also talk about this 183. You'll see this one, but 404 not found is what you'll find on your web page if you go to a server and it's not reachable. So they're exactly the same responses that we're using here in this particular case. The thing to note is that from 2 to 6, these are all reliably sent messages. So when you send a response back, you acknowledge that you've received it. These 1XX messages are not reliable. So when you send a 100 ringing, a 183, for example, ordinarily, what you don't do is respond back from the phone to say, I've received your message. And that has an impact on how you can use that, how you set up the call, and we'll delve into that in a bit more detail as we go through. So you could set up calls between 2 phones directly. You could configure 2 phones, not Cisco phones, but you could take 2 basic SIP devices and configure them with all the information that they need to speak to one another. But for a large-scale system, that really doesn't work very well, not only in terms of the SIP and the dial plan piece, but there's other issues such as certificate management, for example. So how do you manage these devices, upgrading software? So typically what you're going to have in this environment is some kind of server. And if you look in the standard here, you'll see there's the registration server, the redirection server, and the proxy server. So they aren't all physically different servers. They can be in one box, but they're providing specific functions. And so the first one here is that registration server, so not supported on the trunk, but supported by devices. And in that registration server, you bring up your device. The first message that you're going to send is this register. You register your number and the IP address of your device. So now this device knows where your location is, how to route calls to you. It knows that you're alive. A redirection server is just to say that, okay, I'm going to try and call you. You're busy. If I'm calling and you're busy or you don't answer, where do I redirect to? So I'm going to redirect to voicemail, for example. And the last one here is the proxy server. So the proxy server comes in two types, basically. There's stateful and stateless, and you'll see both of those used in various environments in UC. So the stateless environment, where you're not keeping track of the messages that you send, you just get a message and you just forward it on and forget about it, would be CUSP, for example. So with CUSP, you might be using the proxy there basically just to load share requests across cubes, for example. It might be something that you would do. The stateless server is tracking state, and an example of why you might want to track state is that if you sent a call to line 1000, for example, you send that to a proxy, but you've got a system where you have shared lines. So I've got 3 devices that have line 1000 on it, so I send the invite to the proxy. I'm going to fork that invite out to 3 devices. The proxy now needs to keep state to see who responds back to establish the call to, and to tear down the call to the other devices. So you're going to ring all 3 devices, you pick up on this device, you're tracking state, so you'll establish the call here, and you'll send a bye to these devices or a cancel to drop the call down. Ordinarily, the proxy will drop out of the signaling path. So this is not all the call signaling here, we'll see a bit more a little bit later on. So I send an invite to 2002, I'll send a 100 trying, ringing, I get my 200 OK back, and at that point, I'm going to set up media between these 2 devices here. So ordinarily, what the proxy can do here is that it can drop out of the connection. So now the proxy is not in the media path. I've got a connection between these 2 devices. You've exchanged information in the SIP headers that exchanges information about the IP address of this device. And so now if I want to tear down the call, I can just send a bye all the way back to the device and drop out of the call. Again, it's not widely used, and Call Manager certainly doesn't use that function, but in proxies in general, it's not widely used. What you want to do is to have some form of state here. And with state, what you're doing is that you're running record routes. So you run record route on the proxy. It tells the device to basically route all of your messages through the proxy here. And one of the reasons why you might want to do that would be for call detail records. So how do you track centrally what's going on within the system itself, or call maintenance records, a new feature with 11.5 for SIP trunks, for example. So typically with stateful proxies, what you're doing is running record routes, so you're making sure that all of the signaling goes through that proxy. You've got call detail records. You've got a way of debugging issues that are in that system. And now with the call set up here, if I now want to tear down the call, that's going to go via the proxy. So you're tracking the whole state of that call from beginning to end, okay? But the key thing here is that these are the standards, but if you look at Call Manager is not a proxy server. And again, there are limitations in the way that the proxy server works. It can't kind of intervene in the call. It can't switch or change the codec types. It can't terminate a call. CUCM's not a proxy server. What CUCM is what's called a back-to-back user agent. And so the first thing you might want to do is go to 3261 and say, okay, I want to read about this back-to-back user agent. It's basically a small paragraph. It doesn't describe how the B2B UA works. It just describes it in principle, what it is. And in principle, what it is essentially when you make a call between call manager, or this could be Cube, for example, as well, the way that the B2B UA operates is like two individual call legs. So I'm making a call from this device to essentially this device over here, and to forward the call on or to extend the call to this device, I'm re-originating a brand new call from the call manager over to this device here. So why are we doing that in Call Manager? The main reasons are, well, there are multiple reasons for doing it. So one is that Call Manager is not just SIP only, as we know, it's H223, it's skinny, it's MGCP. But likewise, we want to have more control over those calls. By terminating the call signaling here and re-originating it on the outbound side, it means that we can modify things. So we could modify the codecs based on the region settings that you've got. We can modify the DTMF settings. There's a lot that we can do. So we have more control over the calls by running Call Manager as a B2B UA, or Expressway as a B2B UA, or Cube as a B2B UA. So that's why we're using that. And again, last slide here. If we look at line-side SIP and trunk-side SIP, again, for any vendor, what you'll find here is that line-side SIP will tend to be proprietary. So there'll be lots of proprietary extensions to the line-side development of SIP itself. So there's lots of additional features that you need to run over SIP to get that working. So you will have things like registration, reset, restart, for example, failover, erase your config, lots of stuff. So if you were to take a phone and plug a Cisco phone into Call Manager, then you get all of these additional features. If you took a third-party phone and registered that with Call Manager, then you're going to get a subset of those features. So we do support third-party phones, but we kind of talk about the standard 9 features that you would get, hold, resume, transfer, and so on. Again, if this was not a Cisco phone and a third-party phone there, how do you manage the certificates in that phone? So again, there are benefits to having a Cisco phone on Cisco Call Manager. It just means that it's more easily manageable. Other phones might be cheaper, but then you have the overhead of managing those devices, and that would typically be webbing into that device to upgrade a certificate, change the configuration, and so on. So we're not looking at line side. What we're going to be looking at here is this trunk configuration between these two call managers in general. And again, that's fairly simplified. So what's happened over the years is there's kind of been a de facto set of features and the way that things work. People have put multiple proposals in for how you implement features over these trunks, and you'll see on Call Manager Trunk, if you look at call hold, for example, there are several ways that you can do call hold, and we support 2 or 3 ways in the configuration on the trunk itself to actually implement call hold. But what we found over the years is that it's a simplified core set of features that are running over that SIP trunk that provide you with that interoperability. Okay. How am I doing on time? Okay. So I'm about a quarter of the way through, and I'm a little bit behind, but let's carry on anyway. So this section, we're going to just start looking at like setting up a call, look at the basic signaling. I'm going to drill down a bit into some of the headers just to give you an overview of what the headers are. And in places, what I'll do is draw out how the configuration on Call Manager will affect those headers. Again, in the appendix, that's covered in detail. So if you want to look at how configuring something on the trunk will modify what you're sending in those headers, we can take a proper look at that. But the first thing is, this is the environment that we're going to be looking at over the next few slides. I've got a phone here registered to this Call Manager on 251. I've got a SIP trunk set up pointing to 250 over here, and I'm going to make a call between 2002 and 1001. So we see the first thing that we're going to send here is the request, which is an invite to invite 1001 into a call, and what it's being sent to here is this address of this Call Manager over here. So we're going to take you through that, but if I look at that invite in more detail, what you will see, if you were to look at a trace, is something like this. You'll see the invite itself, and then you'll see all of these headers. So these headers generally aren't in order. They're not, some are mandatory, some are optional, so you can certainly have ones that are proprietary. We have Cisco headers in there. We can also do things like take information like call info, for example, and tack on information into those headers that we might use in a proprietary way. From vendor to vendor, it doesn't really matter so much. If you don't understand the header, then you can just ignore it. You're not going to fail the call if you add an additional header in there and the far end doesn't support it. But there are certain things, such as the via header, the from and to headers, for example, the call ID, that every message has to support, and we'll go through those. So what I've done is taken these, and I've kind of regrouped them a bit into kind of logical categories. So the first group here is this sort of root and transactional rated headers, and then we'll look at the from and to headers, the call ID, the identity as well. But again, in the appendix, you'll see that I go through every one of these lines, describe whether it's mandatory, optional, how call manager configuration can address or change those configurations. So the first one is, of course, the request line. So this is my invite in this particular case. And here, if you look at that, if you look at the individual pieces, so we're using SIP. This is the user that I'm calling. It's showing a number here, but it can be a number or a name. It defines the called user. The host here is the address of the far end. And so this is going to be the configured SIP trunk destination address. And the port number here is 5060. So by default, the port number that you're using for TCP or UDP will be 5060. You can modify that, and typically what you'll see is that for UDP and TCP transport, it'll be 5060 as the destination port, but for TLS, you're typically using 5061, but there's no reason why you couldn't change that if you wanted to. And again, if we look at the configuration in Call Manager here, you can see that here what I've got is the destination address of 10.10.199.250, but I could put a DNS SRV or a fully qualified domain name in there instead, and that will change what's sent. So if you've got a DNS SRV or fully qualified domain name, you'll see in the invite request and the to header that you're sending cisco.com here, for example, and you just resolve that at DNS to forward the packet on. Next one is, the next concept in SIP is the idea of transactions and dialogues. So if you look at a call being set up between two devices, so let's say that I'm going to make a call between these two devices, so I send my invite, I send a number of other responses back, I get my 200 OK, my ACK. Setting up this call, this is one transaction. If I then place the call on hold, so I'm going to hit the invite to place the call on hold, I go through all of those steps again, that's another transaction. So you'll see this transaction 101, 102, for example, and you'll see this in what's called a C sequence header, and we'll talk about that briefly. But these are two transactions that are part of a dialogue between these two devices. So we have this concept of defining a transaction, which is setting up one individual transaction between two devices, and then multiple transactions grouped together, which form a dialogue. Okay. And if we look at those transactions here and look at how that relates, how those are kind of borne out and displayed in the headers here, the first one here is in the command sequence header. So in the command sequence header, what you can see here is C sequence 101 invite. So in the first transaction, you'll see C sequence 101 invite. When I place the call on hold, you'll see C sequence 102 invite, for example. And actually, did I miss a slide? Yeah, I did miss a slide, so excuse me. And the other thing that you'll see here is the via header. So again, the via header, in a world of lots and lots of proxies where your call is passing through multiple proxies, if you want to record route and go through those proxies, what you would see as I send that invite request out, that each proxy will tack its IP address into the via header here. But in the call manager environment or with back-to-back user agents, then really what we're doing is I've got a call between the phone and call manager and another brand new call unrelated between one call manager and another call manager. So in the via header, what I'm seeing here is the IP address of the originating call manager, and you'll see that in all requests and responses here. But what it also contains is this branch, and it's this branch here that also identifies the transaction. So that, your question?
Do via headers get updated for calls between users or different subscribers within a single cluster, or is it only from one call manager to another?
So that it's only over, so the via headers, it's not between the subscribers, no. So it's only over the trunk itself. And again, if you looked at all the requests and responses that went back and forth, that via header will be exactly the same. You'll see the same branch information and the same IP address. So I send an invite out, it's going to be from 251, but you see a response come back from 250, the via header will have 251. It's really built for an environment where what you want to do is that if you're going through multiple proxies, you know how to get back to the originating device. But in our environment, there is only one hop because I'm going from one B2B UA to another B2B UA. So the key thing here really is the branch thing. That's what we're doing there to identify the specific transaction. And then in addition to that, what we're looking at is that C sequence number to also map that as well. So those are transaction related. That's how we identify the transactions. How we identify the dialogue is through the to and from header and the call ID. And so with the to and from header, what you'll see here is that they're exactly the same. They're mandatory in requests and responses. But the key thing to note here is that if you start looking at traces, and if you're kind of like new to it and you're looking at SIP traces, when you look at that to and from header, it's easy to get confused because you'll see that to and from header doesn't change. So it's not from, in the request that goes out, it's not from 251 to 250, and the from coming back, and the request coming back from 250 to 251. What you'll see in that response coming back, it'll be from 251 to 250. So it's always the same in requests and responses. It doesn't indicate the direction of the message. It indicates the direction of the call setup request. So it's always from the requester to the far end called system. But what they also include here are these tags. And these tags here, so you can see outbound and from here that the calling call manager has inserted a tag here. And when we see a response come back, which you'll see in the appendix slides, there'll be a tag on here. And these two tags identify the dialogue between those two devices, okay? And what we also have is the call ID header. So in the call ID header here, we also have this ID, which again identifies the dialogue between the two devices, okay? And again, if you look at how you might configure Call Manager, for example, over your SIP trunk to present information about users, what you'll see are there are multiple places in the header where you're presenting user information. So you have this from field. This could contain a number and a name, but we also have these two values as well. There's the remote party ID and the P-asserted identity. So they're both switched on by default. They both do the same thing, essentially. The reason why they're both switched on by default and do the same thing is that this one came first, and with remote party ID, it provides this function of saying, I could anonymize this information. I could choose to anonymize the name and number that I send in the from header, but with the remote party ID and the P-asserted identity, what I'm doing is I'm going to send that information about the called and calling user in any case, so that if I want to do a call trace, for example, I can see where that call is coming from. Likewise, what I might want to do is that when I call outbound from my call manager to the PSTN, I might want to change the from header to the switchboard number, for example, but I also want to make sure that I'm sending the information about the actual caller into the network as well. So again, for call trace purposes, for example. So they're both there. P-asserted identity superseded remote party ID for one reason. It was that with P-asserted identity, you have the ability to authenticate with another vendor or with the cloud. So what you can do is that with remote party ID, I can send this information out, but there's no way of knowing that this is trusted information. With P-asserted identity, when you establish your SIP trunk, what you can do is have a digest authentication to know that you're connecting to the right service, and therefore you can trust this information. Okay. And again, in SIP trunk configuration, let's take a quick look here at what I've got. Yeah, you have this use fully qualified domain name in SIP requests. If you check this box, what you'll do is you'll change out the message headers in your from, P-asserted identity, and the contact header from the IP address of Call Manager to the top level domain that you've configured in Call Manager here, so cisco.com, for example. So an example of how the configuration in Call Manager changes what we're sending in the headers here. Okay. So next ones are timing-related headers. So we've got supported, session expires, minimum session expires, and expires here. So we'll go through each of these briefly. So if we kind of regroup them, we've got these here. We'll talk about allow events and these briefly as well. But the first one is this timer resources and replaces, for example. So let's just go back and look at these. So you can see in the header, you'll see supported header, you'll see timer, resource priority, and replaces. What those mean in terms of Call Manager configuration are multiple things. So this is timers here for refreshing sessions, and we'll talk about those in a bit more detail. Resource priority is for MLPP. So if you want to override a call, for example, with MLPP, you'll use resource priority, and replaces is a way of just replacing a call that's already in place. So again, you're showing that these are supported. They aren't necessarily configured though. So the timers are generally, there'll be defaults for those, but things like MLPP and et cetera places, even though they're supported and you'll see them as being supported in the header, you have to configure them in Call Manager to use them. But with the timers here, what we have is the session expires timer and the minimum session expires timer. And what you'll see on a call that's established, let's say here, between this Call Manager cluster over a SIP trunk through SME and outbound over this trunk to this Call Manager here, a call in place between these two phones. What you'll do is use these expire timers here on each trunk just to track that the far end is reachable, that it's still alive. And so you can either send a re-invite or an update. It's generally better to send an update rather than a re-invite, particularly if you're going between systems that aren't all Call Manager or SME, because some end systems treat re-invites differently to updates. But basically, you start sending those re-invites and updates between the end systems here, and they're just going to respond back and say, yep, I'm still here, the signaling session's up and active, keep going. But now if your SME node crashes, for example, what happens in this case? And this is where your timers kick in. So now you've got your media established. When that SME node crashes, do I tear down the call straight away? Or do I keep the call up for a period of time? And that's based on those timers. So now what I'm going to do is to send an invite, a re-invite here. I see no response back. I'm going to send a bye, and like us on the far side, and then I'm going to tear down the media. And the way that your customers, or you may experience that, you probably may have experienced this already. You're calling into your bank, it's really busy, you're waiting on the phone, you wait for half an hour, and the call just drops. So a 30-minute timeout is typically what you'll see, and that's the default here. You can extend that. And again, we made some changes in 11.5 to preserve it, so you can set that now to default. So by setting it to 0, basically what we won't do is we just won't tear down the call at all. So it's an option there for you. Next one here, I don't go into detail here, so the details are in the appendix. But if we look at allow, for example, this describes the methods that this device supports. So, invite options, info by prac, for example. So prac may not be configured on this device, but we can tell you that it is available, for example, to use. Allow events here, so presence and KPML. So presence for subscribe, notify, for busy lamp field indication over a SIP trunk, for example. KPML, key press markup language, for DTMF transport. So you're sending your DTMF tones in the signaling path rather than the media path. And then there are a bunch of Cisco ones here. So again, proprietary to Cisco, ex-Cisco SRTP fallback. It means that what you're going to try and do is establish an encrypted media session, but if for some reason you can't establish that, what this header is saying is that if I can't establish SRTP, I'm happy to go ahead with just an RTP call instead. Geolocation is used for defining where that device is calling from, and you'll track that across the system. So let's say, for example, you can't make voice over IP calls from India to other countries. So you need to know that you can't do that. You use geolocation with logical partitioning in Call Manager to enforce that and say calls made to and from India can't be made over the IP network. They must be forced to the PSTN, whereas calls between the US and the UK, for example, that's okay. The user agent, so we do send details about the user agent here. We can go right down to the minor level. Again, probably more used by service providers here. So they might say, okay, if I see a call coming in from this version of Call Manager, I want to treat that call in a specific way. And so we'll see a little bit later on when calls come into Call Manager, there are some very basic ways of accepting that inbound call and associating it with an inbound trunk. But there are ways that you can look at the version of Call Manager, accept the inbound call, and then reroute it to a different trunk with different configuration. Okay. And the GUID basically just defines the call, so it's a unique number on the call itself. And then a few others here as well. So there's the date, max forwards is really to address loops. Call info, what we've got here is actually a method of notify telephony event duration 500. This is a proprietary method of doing DTMF. It's unsolicited notify that we could use between Call Manager and Cube, for example, or the iOS platform. But generally, it's kind of not really used that much today. But we still use the call info header for other information here. We can send other information in this header that we'll use to implement features between Call Manager clusters. And then you'll see content length, and you'll also see content type. That'll become a little bit important a little bit later. But that really describes, these are the headers. But what you'll see after this is what's called the body. And in the body of the message, that will contain typically SDP, and that contains information about the media itself. So we've looked very quickly at that trying request and the headers there. So I send that out, and the first message that I'm going to get back so we sent the invite out, and the first message that I'm going to get back is this 100 trying. If you look at a trace and look at 100 trying, you're going to see very little information. You'll see very few headers, and you'll see no information about this calling device. What the 100 trying indicates to the system here is that Call Manager has received the invite and is processing it. That's all it's just saying is, like, I've got your message, I'm dealing with it, but there's very little information in here. What you'll see coming next is that 180 ringing. And that 180 ringing indicates to this system here that Call Manager has contacted the phone, and it will now, if you look at the headers here, it will contain information about the capabilities of this device in the headers here. It sends it back to the far end. Once it gets to the far end here, what ordinarily happens is that when this Call Manager receives that 180 ringing, it will tell the phone to generate local ringback tone. Okay? So the phone's now ringing. I'm then going to go through. I'm going to send a 200 OK, a success back, and I'm going to acknowledge that. So remember that these 100 messages aren't acknowledged. These messages are. So you'll see this 200 message. They are reliable. So when I send a 200 message, I'm going to send an ACK back to acknowledge that. So you have a confirmation that you've received it. Okay, and once you've got that, what you'll do next is just establish your two-way media. So what we've done here is send all of this signaling back and forth, but right now we have sent no information whatsoever about the codecs that we're using for the call, how we're sending some information on DTMF, but not a lot, how we're doing the codec negotiation, or even the IP address of this phone here hasn't been exchanged. So SIP is just setting up the signaling path, exchanging information about capabilities of the phones and call managers between the systems. The next step that we need to do as part of this process is to establish media between the two devices, and that's where we get down to session description protocol. So session description protocol is typically called SDP. You'll see it being used in SIP, but if you look at Teams, for example, so WebEx Teams, the signaling's not SIP-based, it's HTTP-based, but we're still using SDP. It's a tried and tested method of negotiating media between devices. So, we've got this signaling in place here, but at some point during the signaling exchange here, what we need to do is to exchange information about the capabilities of these devices. And so we're going to have this exchange of IP addresses, endpoints, port numbers that I'm going to be using. Again, bear in mind that this is a back-to-back user agent. So this is one call leg here, another call leg here, and another call leg here. And what does this allow me to do? If this is in a remote branch, I might send my list of codecs up to this device and say, I can do G722 or a wideband codec, but what you're doing in Call Manager here is saying, I know you're in a branch here with very little WAN bandwidth, so what I'm going to do is when you send me your full list of codecs, I'm going to look at the region settings, and I'm going to strip out all of the higher bandwidth codecs and only send G729 across in this link here. So Call Manager and the B2B UA here gives you control over the call and how you're setting up that call. Okay. So this piece is, SDP is defined in 3264. So the two RFCs that you should read are 3264 and 3261. And this is called the offer-answer model. So this is about this exchange of characteristics between the two systems to establish the call. So we'll go for the text. Let's go to that. But the two key things here that you'll see in the offer-answer model are what's called early offer and delayed offer. And if you know nothing else about, if you take nothing else away, understand what these are, because these are the most impactful things in terms of designing a multi-trunk network. Okay, and so what is this? So there are the early offer here. So don't focus on the text so much because I'll be reading this out more or less. But what I'm doing here is that with early offer, I send my invite that we've seen before. But when we looked at the body of that message, we saw that content type and content length, it said 0. Now it's going to say 337 bytes. And what you'll see beyond that is this SDP offer. And what that contains is information about this calling device here. So what its IP address is, what codec it supports, how it transports DTMF, and so on. So I'm going to send this in this invite here. This is reliable. I get a trying and a ringing back. These are unreliable, so I can't send a response back on these because I don't know for sure that it's been received. So in the next reliable message, I'm going to send my answer back. So I send my offer with my codecs, my IP address, for example, my port numbers. It goes all the way to the far end here. This guy's going to select the codec that it wishes to use, and it's going to respond back with its IP address, that selected codec. And when I've gone through this exchange of 4 messages, at that point, I can establish two-way media between these two devices. I send the ACK, and typically I'll start billing. If you're connecting to a service provider, they always want to use early offer. So one reason that they might want to use that is that you're sending them the full list of codecs, and they can choose which codec they want to use for the call. But it's more important than that, and that's that if you look at early offer, I'm sending you in this invite to this service provider up here, the IP address of this phone, the list of codecs that it supports, and the UDP port number for media. So now I'm going to call a number that's non-existent in the PSTN. If I went all the way through here, if I sent a message back to the user saying this number doesn't exist, I'll ACK it and I'll bill the user for the call. What we can do here is do one-way media. So this has all the information that it needs to send a media stream one way back to this device and say, you've called a non-existent number, I'm going to stream that back to you over G711 and say, please try again. So that's one of the main reasons why service providers like using early offer. It means that they can establish an announcement path, send the message back to the user without billing them. So that's early offer. The other one is delayed offer. So the first thing to bear in mind in Call Manager, if you configure a SIP trunk or just bring up a SIP trunk and name it, by default, that SIP trunk is using delayed offer. So you do nothing else, you're going to be using delayed offer. If you want to configure early offer, there are multiple options to do that. But what we're seeing here is now I'm sending this invite, but this invite contains no information about the calling device. So I'm just sending that invite with the header, no body here. I get the 100 trying and ringing, unreliable. So the next reliable message, I'm going to send the offer from the far end. So now the offer of the call device comes back with its IP address, its codecs and port numbers, goes to the calling device, it makes a decision, responds back, establishes two-way media. So one more message that I'm sending here, and that can be important in terms of like long round trip times. You'll see media cut-through delays and so on. We'll talk about that a bit later. And in fact, we'll talk about it here. So we talked about not being able to send the offer and answer in this 100 trying and ringing here. It's because they're unreliable. You can make them reliable by using PRAC. And what PRAC does, as we'll see in the next slide, is it gives you the ability to, so this is SIP delayed offer without PRAC, as we saw in that before. The reason I can't send the offer answer here is because they're not acknowledged. But by using PRAC or provisional reliable acknowledgement, what we're doing is if I send an offer or an answer in those 1XX messages, I'll send an ACK back or a provisional acknowledgement back to the far end, and that will send an acknowledgement back to me to say that it's received my acknowledgement as well. And what that allows you to do is to basically use fewer messages. So in this case, early offer was what's now, if you're using PRAC, it's typically called early media, but early offer and early media are not the same thing. Down here, I can have delayed offer with early media. So I'm doing an early offer, I'm sending my invite with SDP here. I'm indicating in the supported header that I support PRAC. I send my trying back. That's just coming from Call Manager. So there's no information in here about the call. So in the next mission, I'm now sending a 183 back, and this contains the answer here. So I've got 3 messages. At that point, I can cut through the media, but I acknowledge the fact that I've received this in the 1XX message, and this acknowledges back that it's received that acknowledgement as well. And then likewise for delayed offer, very similar. I've now got 4 messages rather than 5 before I cut through media. So it was initially used to kind of cut through the media more quickly. If you think about a SIP trunk between Melbourne and Alaska, for example, then you're going to have a long round trip time. And by using PRAC, you can reduce the number of messages that you're sending and cut through the media more quickly. But it also has benefits in other environments, such as if you're going through Cube, going from delayed offer to early offer, PRAC really helps you out and avoids some corner case situations where the call won't work as you expect. Okay. Okay, and then let's have a look at SDP in detail here. So if you were to look, in green here is the kind of the last few lines of the headers. So you'll see content length, content type, application SDP, and the last header here is content length, 337 bytes. And this is typically what you'll see here. You'll see a series of lines with a single character, an equals value, and a number of lines here. Some are required, some are optional, but they must be in a specific order. And if we look at those in a bit more detail, the kind of things that you'll see here is that you'll see the origin, the name here, it's the IP address of the calling system. You give it a session name, Now, this is important. This is the first time we send the IP address of the phone in the system here. Timing 00 means it's a permanent session, and what you'll see here is media description. So this is an audio call. 16444 is the UDP port that I'm using for media, and this 0, 8, 18, and 101 describe the list of codecs that I'm using, so G711, ULAW, ALAW, and G79 in preference order, and the 101 is used to indicate that I can send DTMF tones in those RTP packets as well. So, in theory, I could send one packet that's using G711, another using G729, another using a DTMF tone. How would you differentiate those in RTP? You'll look at the RTP payload type, and if you look at those payload types, you'll see that 0, 8, 18, or 101. So when you're making a call, it's using a G729 codec. How does the phone know that the packet it's received is not a voice sample, but it's a DTMF tone instead? It's by looking at the payload type and checking that. And again, send receive indicates two-way media. P time is the sampling interval. So this is what I'm sending. And the main things here is the IP address, the list of codecs that this device supports, and whether it can transport DTMF in media as well. And again, that's not a voice, that's not a tone sample that's sampled in the media. What we're doing is sending it as a signaled event for DTMF here. So this is what we're sending out. So it goes to the far end. Again, by default here, we're sending these codecs out in preference order, but the far end system doesn't have to honor that preference. Call Manager, by default, will not honor the preference. It will look at what it wants to do and choose that codec according to how it wants to treat the call. And typically, most other systems will not honor the codec preference list. You can force that, though, in the SIP profile configuration. This is accept audio codec preferences and received offer. If you switch that on, then we will honor this preference, and we'll always use G711, MULAW in this case, rather than using G729. But in this case of the answer, what we see coming back here, so the called phone's IP address, so how I establish my media, I'm going to have a direct media connection. You can see that we've selected to use G729 here, and again, we can send DTMF tones on that media path as well. And that's what this looks like here. So this is what you're seeing being negotiated between these two things. So that's voice, and again, this is something that you should look and go through and understand. It's a kind of core basic along with delayed offer, early offer. SDP is a core functional part of SIP and setting up calls in this environment. This section I've summarized right down, and this is for video calls, so there's a whole bunch of slides where I go through BFCP, far and camera control, desktop share, everything, and you'll see very big, long descriptions of SDP. The SDP starts to get really big in this particular case. But the general rule here is that if you look at video, well, if you look at voice, what we're doing is negotiating a common codec that both of us are using. It's pretty simple to do. For video, it's not that straightforward. So what you'll see here in video is that typically in a video environment, what you'll see is that the upstream bandwidth and the downstream bandwidth are not symmetrical. And again, that's to do with things like encoding, for example. It's typically more CPU intensive to encode than it is to decode. So you could see that you're sending upstream your encoded stream at a lower rate than what you're receiving. So when you're now doing a negotiation, what you're doing in those SDP information, as we'll see in the next few slides, is we're really sending information about the receive capabilities of the device. And what we'll typically see here is something like this. And this, again, this is kind of abridged. So there will be the previous stuff, the session stuff up here. We're now looking at the video lines. This is the port number, and we've got 98 and 99 here. So 98 is H.264, and we can see all of this information here that describes the characteristics of this call. The profile level ID basically defines a basic profile which has a number of characteristics embedded into it. The packetization is how I send samples. Can I send multiple video samples in a packet, only one sample at a time? These two are important, that they must be symmetric, but everything else after that, these are things that vary from the norm in the profile level IDs. This is specifics to this individual device. H.263 is still offered, but by far today, H.264 is what's the most generally used codec standard. It's more efficient in terms of the way that it works. And we can also see down here, this NAC PLI and NAC TMMBR. So I think it's in the next, yeah, here we go. So there is some detail here, but again, much of the same stuff, the IP address of the device, the port number, the codecs here. But these ones here are used for rate adaptation. So if you know about MARI or Media Assure, then with these, what we can do is that we can indicate that we're losing packets. So I've got to, I've established a video call, I'm running at 6 meg, and I'm starting to drop packets. What I can do here in the RTCP stream is indicate to the sending devices, look, I'm losing packets here. And I can tell this guy, look, drop your maximum bit rate from 6 meg to 4 meg. If I'm still losing packets, drop it down again to 2 meg, to 1 meg, and so on. So we're using this TCP back channel here to indicate packet loss and control video rates between devices. So this is the offer that I'm sending out. So I'm sending H.264 and H.263. Here's the capabilities of this calling device. Here's the basic standard that I support. Here are the things that are different, and here's the packetization mode. And in terms of the response here, here's the IP address of the call device, but we've selected H.264. You'll see the profile level ID, and the packetization mode must be symmetric. But again, what you'll see is asymmetric values here for these various things here, and I can't even remember what's the maximum frames per second, for example. But again, in the appendix, these are all detailed. So if you want to delve into video in a bit more detail, please take a look at these. And again, this is the audio now and the video call. It's combining the last two sections. But what you could see is something like that. So you'll see a call here between two devices that's got audio. It's got main video. You're doing desktop share. You've got binary floor control. And you've got far-end camera control. So you could have multiple streams that you're using between two devices. And when you're looking at things like this, and you're looking at things like early offer, delayed offer, or MTPs, then those are considerations in that case, because media termination points do exactly that. The media passes through that device, and you need to know that those media termination points can handle all of those media streams. So iOS MTPs, which we'll talk about, are the ones to use. They can handle up to 16 media sessions per call. Okay. A quick one here. So again, I've hidden a bunch of the slides here. If you want to go into detail on TLS, I go through all of the steps of TLS, how that works. But if we're looking at securing the environment, then there are a number of things that I have to do here. So I need to encrypt the signaling between the phone and call manager, and then encrypt the trunk between these two call managers here and down to this far end. So it's in this signaling path that we're going to exchange the encryption keys that we use to encrypt the media between these two devices here. So again, that's using what's called SDES. And again, SDES is pretty much standard these days in terms of what most people do. But the key point here is that if you're encrypting from the signaling from the phone to call manager, but you're not encrypting over the trunk, then your keys are going to go in the clear. And somebody can see those keys. They can intercept your media and decrypt your media. How you configure that is on the SIP trunk security profile. There are a number of different things here. So you have the incoming and outgoing transport type. So by default, that's TCP and UDP or TCP. There are some recommendations that are generally made. If you're connecting to a service provider over a SIP trunk, they'll typically always ask you to use UDP rather than TCP. And the reason for that is that it's only going to be voice calls, and so those packets are going to be relatively small. You're not going to need to fragment those packets and reassemble them, and so you'll send them over UDP. And again, by using UDP, it's less CPU intensive for them. In the enterprise, you could be doing encrypted calls, main video, desktop share. So what you're going to start to see is that SIP header and then the body really extending down. And in fact, if you look in the appendix, I think actually scroll beyond the slide because there's just so much information there. And so now what you may do is go beyond that 1500 bytes limit. And if you're using UDP, you're requiring the upper layer to reassemble that information. If you're using TCP, you can fragment those packets and reassemble them at the transport layer instead. So it's better using TCP within the enterprise. It's a little bit more CPU intensive, but that shouldn't affect you. The incoming port number is by default 5060. If you switch on TLS, that's going to be 5061. There's other stuff here in terms of accept out of dialog refer, unsolicited notify. But generally, if you're switching this on, you're going to be using TLS. And the way that TLS works, it's an exchange of certificates between the end systems. We look at the names in the certificates to match you to a specific trunk, and then we can negotiate keys and establish a secure path of signaling to exchange those keys for media. And what you would see in SDP, along with all the other information about codecs, would be these lines here. You'll see A equals crypto 1, crypto 2, and crypto 3. Here are the various types. So there's AES 256 GCM, 128 GCM, and then 128 HMAC SHA-1. This bottom one here is pretty much the kind of worldwide standard for encryption today. These two are newer ones that were kind of introduced by the NSA. They're well, recommended by the NSA, they weren't introduced by them, but they're more efficient in terms of the way that they work, and clearly they're stronger in terms of the key size for 256. But what I'm sending here is the encryption cipher that I'm using, and what follows that is the encryption key for the session. So that's sent over the signaling path. If you run encrypted here, I can read these. So again, I send out, here's the type size support, here's the keys for each of these ciphers, and then the answer that comes back, it says, okay, I'm using AES 256 GCM, here's the key that I'm using, let's go ahead and encrypt and decrypt at the far end, okay? Okay. Okay, so I'm just trying to work out how I'm doing on time. 1 sec, I'm gonna check which slide I'm on. Okay, we're about on track, which is good. So that was kind of the introductory piece. It was kind of the theory on SIP signaling, SDP, SRTP, TLS. What I'm now going to go through is some of the features that you're going to be looking at in Call Manager, the various options that you've got, and then as we go through, I'll recommend specific ones that you should be using. So let's look at the first one. So the first one we're going to be looking at is delayed offer, early offer, and best effort early offer. So as I said before, if you bring up a SIP trunk in Call Manager, give it a name, and do nothing else, you give it a destination IP address, by default, you'll be using delayed offer. So with delayed offer, you send an invite, you don't send any SDP. If you want to configure early offer, you have essentially 3 options that you can use, and those are kind of they have various ages. So the first one that you could use for early offer is something called MTP required. And on the trunk configuration, you'll see that checkbox, MTP required. This goes all the way back to Call Manager 5 or 4 even, I think. And this is the way that we did early offer back in the day. And when you check this box, if you made a call from a SIP phone, a skinny phone, a SIP trunk, MGCP trunk, whatever you make outbound over that SIP trunk, you will insert an MTP for every inbound and every outbound call. Clearly, that's pretty, it's going to use up a lot of MTPs here. So people didn't like it that much. There were also some limitations in this MTP, and that this MTP could only support a single voice codec. So you couldn't run a video call, you couldn't run encrypted media. It's a single voice codec only. So it's not recommended today, it's pretty much obsolete. There is one reason why you may want to use this, and that's if you want to anchor the media to one specific IP address. So you would run all of your MTPs. So, oh, by the way, you have choices of MTPs in either Call Manager, which are there by default, or in iOS. General rule of thumb is don't use the MTPs in Call Manager because you're now running media through your Call Manager servers. If you run them through the iOS box, it's a separate platform, and they support more features as well. So what you could do is to run these MTPs in a single router platform. You can run up to 500 sessions here, 500 MTP sessions, and now you know that your media is going to originate from and terminate on that MTP, so you can use that to track traffic. With this MTP using this feature, it's only voice calls, so it's not good. So if you really wanted to do this, the way that you could do it is instead of using an MTP, a media termination point, you could use what's called a trusted relay point. And a trusted relay point can either be assigned to the phone or to the trunk, and a trusted relay point is just an MTP with a different name. So look at this here. Rather than MTP, you don't check this box. You'll check a box in the SIP profile that says trusted relay point. It will insert an MTP, but that MTP has more capabilities. It can support voice, it can support video, it can support encrypted streams. And again, so again, a way of anchoring media if you wish to, don't use this method, use a TRP instead. So again, if you look at early offer and delayed offer and look at the spec, it's mandatory in the spec. You have to support both of them, but what you'll find is that question. Okay, so the question was, does the trusted relay point or the MTP have to be hardware-based MTP or iOS-based MTP? It doesn't need to be hardware-based. So hardware-based implies cost. So you'd have to have DSP farm in your iOS platform to do that. The MTP or the TRP, they're both the same thing, is just use the software base. So it's free, there's no license for it, and you can scale up to 500 calls typically on a platform, okay? Sorry? Yeah, so the question was, do we also support video and SRTP? The MTP itself is called codec pass-through. So if you switch on codec pass-through on the MTP, it basically ignores what codec you're using. It just doesn't care. It takes an RTP packet, it just sends it through to the other side. When we first did the MTP in the previous version, MTP required, we only supported one single media channel. But what we needed to do is to add multiple media channels, as we saw for that video call, where we had voice, video, desktop share, and so on, to support multiple media channels. So now, I think for a single call, we'll support up to 16 media channels per call. So yes, switch on codec pass-through in the iOS-based software MTP. It doesn't cost you anything, but you can support voice, video, and encrypted calls. And again, if you're using this feature, which is early offer insert MTP if needed, it's doing exactly that. What you're now doing is you're looking at the calling device, and if it's a SIP phone, for example, the SIP phone sends early offer. So if I'm sending an early offer outbound, there's nothing I need to do. I just forward that on. I might make some modifications to the codecs here, for example, but not a great deal that I need to do. The newer SIP phones, again, can send early offer, but the older phones, 7940s, 7960s, they don't send all the information in the call setup to send an early offer without inserting an MTP. And so now what we'll do is we'll set an MTP for those devices that need it. So older phones, inbound delayed offer trunk, inbound HTTP slow start trunk. So we're using far fewer MTPs in this case. You can use the iOS-based MTPs, the software MTPs. You'll do the codec pass-through. But again, it's good for voice, but it's not that great for video. So you can establish the call, and then you can upgrade to video later on. But this has been widely used up until 10.5. And up until 10.5, your choices as to whether you would use this would really be based upon the number of newer and older skinny-based phones that you had. If you had tens of thousands of 7940s and 60s, if you switch this on and you have thousands of calls going over your trunk, you're going to need thousands of MTPs. And so in that case, I would say don't use early offer, use delayed offer instead. If you have all new skinny phones or SIP phones, then go ahead and use it because you're not using any MTPs. There's nothing getting in the way here. So this was with 8.5 and above, so we did improve things a bit, but it's really in 10.5 that we kind of make things a lot simpler. So we kind of, chatting to the engineers, we kind of realized that if you looked at all of the phones, all of the Cisco UC devices, Cube, anything that's out there, all of the applications, voicemail, conferencing, they all support the receipt of delayed offer and early offer. There aren't any systems in the Call Manager product set that says, I can only receive early offer or I can only receive delayed offer. So it really, you don't have to mandate in this environment that you send or receive a delayed offer or early offer. And what we can do here is configure on these trunk what's called best effort early offer here. And really what we're doing is just looking at the device, and if we can send an early offer, it's a SIP phone, we'll send an early offer. But if it's an older, an older SIP phone here, well then, rather than inserting an MTP, we won't do that, we'll just send delayed offer instead. Now, it complicates things a little bit because you're now saying delayed offer and early offer, and you need to be aware of that, but what it does, it just eliminates any MTP usage. And when you think about those MTPs could be in multiple places, as we'll see, and you could start hairpinning your calls in undesirable paths. So the goal really is to avoid using MTPs for early offer or delayed offer, is to avoid using MTPs for DTMF translation, and to avoid using transcoders. That would be the goal in any design. 6 or 7 years ago, we would say, well, put about 10% there just in case you need them, because you're probably going to need them in this environment. Today, on these phones, they all support, the newer phones support early offer. They support G711, G729, and more codecs. They support in-band and out-of-band DTMF. So these phones have the capability to do pretty much whatever you need, and they can negotiate the codec type, the DTMF transport type that you need to, so that you don't need to insert any form of transcoding or media resource to convert anything in a network. And we'll talk about that a bit later. Okay. So the recommendation today, if you're on 10.5 or above, which you should be, so 9.x went end of support in December of last year, so you might be on 10.10 or 10.5. That's been announced, end of sale a couple of months ago, and it goes end of support, I think, in about 2 or 3 years' time. So 10.5 is coming to the end of life. Can I get a show of guilty hands of who's got code that's pre-10.5 or pre-10? Yeah, there are a few. There are lots of people out there that are still running on 6.1, 7 and 8. If you upgrade, the only downside to that is that if you call TAC, it's like you're on your own. So, yeah. Okay, and this is just a summary here. So this is a bit of a wordy chart, but really, if you're using 10.5 or above, the key takeaway here is use early offer. Don't use MTP required. There are much better ways to anchor the media if you need to do that. If you are using these early versions, then consider the phone types that you've got to make your choice. Okay, features that you should have enabled all of the time. So these got introduced in 8.5. It was primarily around the development of SME, Session Management Edition, that these came in here. So prior to this, what you would have is a single SIP trunk that would have one destination IP address, and that trunk could be active on up to 3 of these nodes. So if you start looking at SME designs and how you're routing calls, to call from here to here in pre-8.5, I would need to have 1, 2, 3, 4, 5 SIP trunks. Each of those SIP trunks would run on up to 3 of these, and it all starts to get a bit messy. You start routing calls between the nodes within the cluster. So run on all unified CM nodes was introduced in 8.5, and it makes your life so much easier. So if you're not switching it on, you have to have a really good reason not to switch that on. Switch it on in all cases. It's there on the trunks. It's also there on the route lists, and I'll show you what that is. And again, up to 16 destination addresses. The 16 was chosen because what you can have is a maximum of 16 subscribers in a mega cluster. So this SME can have up to 16 subscribers. These call managers can have up to 16 subscribers. So you can have a single SIP trunk that's pointing from 16 subscribers here to 16 subscribers over here, okay? And by doing that, and in particular by running the route local rule, you take advantage of what's called the route local rule. And the route local rule basically eliminates call setups between nodes in the cluster here. And the way that that rule works, it says, so I've got this phone registered to this top call manager cluster. I'm going to make an outbound call to SME over this trunk. It just says, is there an instance of my selected outbound trunk on the same node that the inbound call arrived on? And in this case, there is, because I'm running on all nodes, which means if there is, just route it outbound. Send your invite from this node. So now what you know is that whichever subscriber your phone's registered to, that's where you're going to send your outbound SIP trunk invite from. So again, evenly distributing these phones, if they're all used evenly, you should see an even number of call setups being made over that trunk from this device. With destination addresses, for SIP trunks, what we do is randomly distribute across the IP addresses. There are ways, if you wanted to set this up so that you could say, use this subscriber first, this one second, third, fourth, and fifth. But most people do this. You get an even spread. So the call hits this destination SME node here, and I'm going to route it outbound over this trunk to this cube here. I run the route local rule again. Is there an instance of my selected outbound trunk on the same node that the inbound call arrived on? I'm running on all nodes. There is. So I'm just going to route it straight out, choose a destination address, and go straight out. And what this avoids here, again, is routing between these nodes here. And so run on all nodes allows me to provide an SME cluster that's clustered globally over the WAN with up to 500 milliseconds round trip time, as we'll see. So this is run on all nodes on trunks. It's also there on route lists. So always enable it on route lists. If you don't, what you can get is a situation whereby all of your calls outbound are going to route through one of these nodes here. So the rule here is that if you've got multiple trunks in a route list and a route group, enable run on all nodes on that route list. But as a general rule, always enable run on all nodes. Okay. The next thing is I've got a SME cluster or a CUCM cluster, and I've got 1,000 trunks configured on that cluster. When an inbound, so I receive, it comes in over IP, I receive a SIP invite that's destined to a particular address to an IP address. How do I match that inbound call to one of those 1,000 trunks that I've got configured on that SME cluster? And the way that that works is that what I've got here on this side, I'm running on all nodes, and I'm pointing to these 3 destination addresses. On this one, I'm running on these 3 IP addresses, and I'm pointing to these ones. When a call comes inbound into this cluster here, let's say to this node F, the way that I'll match it to a configured trunk is I'll look at the source IP address. And so the source IP address I see that invite coming from, I'll see whether it matches a destination address in the configured trunk here. And that's how I match that basically match an inbound call to a specific trunk and apply those rules and configuration that you've applied on that specific trunk. So it's important to do it, and in SME designs in particular, it has some significance there because in SME designs, you could be routing calls in one way or another. You actually need to have trunks to all of the SME nodes. So even though I'm routing calls one way only, I could receive calls from other nodes and need to be able to accept those inbound calls, but we'll talk about that. Other one is options ping. So switch it on. If you're running H.323, and the reason you don't want to run H.323 here is that if you have this kind of environment, you're running on all nodes, you try the top node. If it's not there, you're going to time out and try the second one. You're going to then time out and try the third one, fourth one, and so on. With options ping, you're tracking reachability. Each of these nodes is going to ping each of these destination addresses. As long as I've got one of these nodes up, I'll keep the trunk in service. You will know if these nodes are down, and you won't send calls to ones that are down. And when all of the nodes are down, you'll take the trunk out of service. If you have multiple trunks and route lists and route groups, you can fail over to your next one. So I think always switch that on. DTMF. So we talked about this briefly. There are two ways that I can send DTMF between this phone and this IVR over here. So I can do, let's see if I get the build right. Yeah, well, actually, it's both of them here. So I can do in-band DTMF. So that's using that RFC 2833. You know, we saw that DTMF 101 payload type. That's in-band DTMF, and that's RFC 2833. This is the standard that we've adopted. There is an updated RFC, but this is the one that we've adopted on Call Manager. But really what we're doing there is we're taking a voice, an RTP packet. It's not a voice sample. It's not just sending a tone, like a voice tone, in a voice sample in RTP to the far end. What the phone does is that when you press the number 1, it will convert that into some binary digits, a signal. It will mark the RTP packet with payload type 101, and it will send that signal over this media path up to this IVR. When this IVR receives it, it will say, oh, that's payload type 101. That's not a voice sample. It's a DTMF tone. I need to read that and understand what it is. So that's one way of sending it. The other way is sending your DTMF tones via the signaling path over SIP. So we saw in the supported options KPML. So this would be key press markup language. So now when I send a tone here, I can either send it this way or I can send it this way. And you'll see that negotiation going on between the two devices in terms of, in those headers, you'll see that whether you can support KPML or not. And likewise in the SDP, you can see whether you support DTMF or not. But you have several options here. The takeaway is use the default, use no preference. So no preference, so you can use RFC 2833 only, you can use out of band and RFC 2833 or no preference. You might think that this is a better option to say, oh, do both. This actually says exactly that, do both. And what that means is that if you have a far end system up here that doesn't support both methods, what you'll do is insert an MTP and you'll translate so that you can translate between one type and another. So this one is not a good option generally to choose because you're going to start using MTPs and diverting your media path. Some customers just choose to use RFC 2833 only and just have that only. If you have no preference, you're just looking at the capability of the phone here. And this phone can support both in-band and out-of-band. So if I'm talking to something that does in-band, then I'll use that. And the preference is always here to use the media path to exchange digits. But if this IVR didn't support it, then I can use out-of-band here as well. If this IVR didn't support it and this phone didn't support it, then what I would need to do is insert an MTP, capture the signaling here, convert it, take it out of the signaling path and put it into the media path and send it this way. So go with no preference. If you go with no preference, you can generally negotiate anything, and you'll never insert an MTP into the media path. And again, you could be inserting an MTP up here. So a call between two phones, this could be New York, this could be LA, this SME node could be in Australia. If you're using an MTP up here, you're going to hairpin your media via Australia, and you don't want to do that. Okay. Codec preference lists. This is, if you look at the codecs that devices support, sorry, I think I've jumped ahead a slide. If you look at the lists here, it lists all of the codecs that we support in Call Manager. So when you think about that SDP, we're not sending 35 codecs in that list. But what you can do is you can order or reorder the preference here. So rather than having G711 ULAW, ALAW at the top, you can say, my preference is to use G729. And the reason that we introduced this was that if you think about a branch office with fax machines and phones, for example, the fax would be G711, the phones would be G729. The way that you had to do that in the past is have two separate trunks, one to route your calls with G711 for fax calls and one for G729. So you've got two separate trunks, but it's further complicated by the fact that you now need to differentiate your numbers. So if I'm calling a number that's a fax machine, I need to fragment my dial plan to route calls down one trunk for a fax machine and another one for phone calls. So this simplifies things. You will define the audio codec preference list, and then you'll assign that either within the region, so default to default here or default to region 1. And we have other values here as well, so you can have the maximum audio bit rate here, the maximum video bit rate, and again, you'll see those, the video bit rate reflected in the STP that's sent out across here. But what does that mean in real terms? So this would be a typical situation here. I've got a phone in region A, I've got a trunk in region C, I set my region so that the audio codec preference list between region A and region C says prefer G722, G711, and G729, but this device only supports G711 and G729. So I'm not going to send G722 out of here because this device doesn't support it. So when I send my invite here, in preference order, I'll send G711 first and G729 because they're both within that 64 kilobit bit rate. If I modify that bit rate down to 40 kilobits per second, then I'm going to exclude the G711 here. So even though it's supported by the device, I'm just going to send G729 in the offer, okay? And this is typically the way that it's going to be used here. So you've got a single trunk now between two call managers, but the faxes can prefer G711 and the phones can support G729. It's also used in SME environments. So SME environments, what you're doing here is you're checking that box, accept audio codec preferences as received offer. We talked about that before. In SDP, you send your codecs in preference order, but by default, Call Manager will not honor those preferences. It will choose what it thinks is best based on the configuration that you've done on the box itself. If you check these boxes, then we're going to honor these preferences here as calls pass through the SME cluster and go to the far end. And likewise, that's also supported by Cube. So if you're making a call to Cube, then Cube will honor the preference order in that preference list first, and then look at the voice class codec second. Okay. Okay, so we've got about half an hour left. I'm trying to work out where I am on time. Let me just check the slide numbers. Okay. So we're at 94 of 320, but fortunately there's about 150 odd slides in the back end. So here we're going to take a quick look at number presentation and restriction. I'll go through it pretty quickly. There's a couple of key takeaways. So in summary here, when you're making a call outbound over a SIT trunk, ordinarily you may send the name and the number, but you can anonymize the number and just send the name. You can anonymize the name and just send the number, or you can anonymize both. So, and you may want to do that calling out to the PSTN or calling between systems. And there are 3 places where you can do that. So you can do it on the line, and that's using a translation pattern typically. You can do it on the trunk, and there's also an additional configuration on the trunk with the P-asserted identity. So if you, again, P-asserted identity is enabled by default, but in that P-asserted identity configuration box, there's also a privacy parameter. And as a general rule of thumb here, if you just configure the line only, then you're fine. What you configure in these translation patterns will be set up and sent over the trunk. But if you then configure the trunk settings to either restrict name or number or both, that will override the line. If you configure the privacy settings in PAI, that will override both. So just be aware of what you're doing in each of these cases. And I think the next few slides kind of just shows this at a graphical level. So there's one sort of aberration here that you can do. A transformation pattern can modify the calling line ID, but it can't modify present or restrict the name. So if you want to do both name and number, do a translation pattern. You can do that on the trunk. So again, you have the calling line ID presentation and calling name presentation. This will override the line configuration. And the last one here is this privacy setting in PAI. That overrides everything. And there are some critical ones here in that the far end must also support PAI for this to work. Okay. Typically, the kind of things that you might want to do is this, that I'm calling outbound from my cluster out of Cisco UK, and what I don't want to do is to present your number and your name in that from header here. So when the call's received by the system, rather than seeing Bob Jones 2002, what it's going to see is Cisco Systems UK and the switchboard number for the UK. And on the trunk configuration, you can set that up apply the number and the name, and if you check that box here, what you'll do is you'll maintain that original caller ID for trace purposes in the PAI and the remote party ID. And further to that, you can do more complex ones. So I've got a centralized trunk now for all of the UK. I've got an office in Edinburgh and one in London. And what I want to do is that calls made by Bob show the London office, calls made by Peter show the office and the number for Edinburgh, for example. So again, I'm not doing configuration now on the trunk. What I'm now going to do is go to the SIP profile for the phone and configure it on the profile of the phone here instead, okay? Okay. Briefly onto Lua scripts. Hopefully you'll never need to use them. You shouldn't, I'd say maybe 5% of customers use Lua scripts, so it's not a lot of people that are using them. There is a guide here, so go to this URL. The one that's typically used is the normalization script. So normalization script, the things to note here on these scripts is that you run the Lua script first before anything else, before you do number translations, before you do anything for any inbound and outbound packets, you're going to hit that script first. It's powerful in the sense that you can do conditional branches. You can say, if I receive this on an invite, then send this in a response. So it's very powerful in terms of what you can do, and it's been good for us from a development sense in that for minor tweaks and changes, we don't need to go and write code and add an extra very small feature into the trunk. It's pretty straightforward to create a Lua script to do that. The other one here is transparency, and that's really for environments where you've got, let's say, Microsoft and Nortel here, or two Nortel switches that are going through SME or a call manager, and they're sending proprietary information in SDP. With SDP transparency, there's actually there's some scripts for that. There's actually a checkbox on the trunk now that allows you to do that. But you can pass that information through. So ordinarily, as a back-to-back user agent, this will terminate this call and re-originate this one on the other side. What it will also do is to normalize all of that information. And so anything that's proprietary coming in here would be dropped. So you can do SDP pass-through. Anything that you receive in SDP, just send it through to the other side unmodified. Okay. Okay, and then a few slides. So there's, for feature invocation, the main thing I want to talk about here is just the nature of how we do feature invocation over trunks. There's a bunch of hidden slides here, but I'm just going to do a hold resume and show you one specific feature and how we typically use it. So first we'll do hold resume. So I've got a call in progress between these two phones. I've got a SIP trunk between this call manager and this call manager. My call's in progress. So what happens if I press hold here? Oops, excuse me. Let's try and do this right. If I press hold here. So if I press hold, what you'll see being sent from the phone to call manager is an invite with SDP to saying send only. So I'm only going to send information. I won't receive anything. But notice what I send over the SIP trunk here. It's not send only. What we're sending here is an invite with SDP. But the key bit in that SDP is this line here, A equals inactive. And so what we saw before in SDP was send, receive, which means it's two-way audio. You can have send only, receive only. Inactive means cut your audio altogether. I'm not going to send or receive anything. So it goes to over this trunk to this call manager over here. To this phone over here, we're going to say, cut your video. So A equals inactive, just cut your video. It's going to respond back with a 200 OK saying, I've cut my video. It's going to go all the way back. I'm going to receive only here. I cut the media through. First thing to note is that this is one way of doing it. You can have the option here, and the very early way of doing this was basically to set the IP address of the device in SDP to all zeros. But that created problems. So you have the option to use this method, but you can also send all zeros as well if you wanted to. So again, for interrupt purposes, you can switch that off or on if you need to. I think it's on by default, but you can switch it off if it causes you problems. As this is this older method of hold here. So now the call's been torn down. And again, for all features over the SIP trunk, we're keeping it simple. So it's really a make and break method or a break and make method. So we've made the media path to go on hold. We're just saying cut the media down. At this time, we're now going to go and resume the call. So we're showing a resume here. We're reestablishing the call between the two phones. A typical environment, but this media here may not be between the two phones again. It could be redirecting you to a music on hold server, for example. But again, if I hit the resume here, I'm going to send an invite with SDP here, but note that what I'm sending to this guy is an invite without SDP. It's a delayed offer. So what I'm sending on this trunk, the configuration of this trunk for early offer or delayed offer only applies to the initial invite that we send. Beyond that, Typically for things like hold resume, we're going to send a mid-call invite will always be a delayed offer invite. And the reason that we want to do that is that when we send that invite and it gets to the far end, we want to get back the full capabilities of this device. And again, there's some notes here about, there's a lot of debate about this, or there was certainly, and if you look at 3261 and 64, there are kind of differences in the text. Some say may, and some say should, and so it's interpreted differently by different vendors. But what we should see coming back in this invite here is an invite with, as if it's a brand new call. So it should say send receive, and it should have the full list of codecs that you support. So what we're doing here, we're doing send receive, we act that back with our SDP, we establish two-way media, and we resume the call. But think about this, the previous call here being, the first call being a call with G711 or G729, for example, and now what I want to do is place that user on hold and connect them to a music on hold server. What I want to get here is a list of your full codecs. I want to see whether you support G711, because music on hold is going to sound a lot better with G711, and that's why this response back here with this SDP should contain the full list of codecs, because this may not be resuming media between these two devices. It could be resuming media back to a music on hold server over here for the period of time that you're on hold. Okay. And so we've run into issues with this, and this is a feature that you probably won't use, but it's just to give you an example of the kind of things that we do. There's a feature called send receive, and mid-call invite. And this is to address this specific issue. So what we saw before was that we place the call on hold, we send A equals inactive, we get A as inactive back, and we tear the call down, tear the media down. So that's all fine, and that all works very well. But now we're going to try and resume the call. And the issue here is that how this end system here operates and how it responds in relation to the phone. So now I'm going to send, I'm going to send my resume here. I send my SDP with that invite here, but this guy responds back not as if this is a new call, but responds back with the last known state. And so rather than sending A equals send receive here, it sends the last known state back, A equals inactive. It may also send just the last codec that it's used as well, but with A equals inactive, I can't reestablish the media. So how do we fix that? And the way that we fix that is that you check the box, send receive, and mid-call invite. Now what you're going to do is that you're going to insert an MTP. You do A equals send receive here. That goes all the way back. You act that back. And now what you're going to do is that you're going to tear down the media between this device. Just hold up the media out here. So you're keeping the media established between the distant phone and this MTP here while you place the user on hold. So they're not hearing the media coming from this device. It's just terminated on an old device here. Nothing's coming to this user. And when I resume now, again, this addresses the issue. So now, what we should see here is that I hit resume, I now send invite with that SDP, it responds back rather than its last known state, which is send receive. I do send receive, I can now reestablish the media, I will do the build. Yeah, drop out the MTP and then reconnect the media between the two devices. So again, you probably will never hit that in the real world, but that's kind of an idea of what we do on the trunks themselves. And in the appendix, I go through bunches of these and explain to you how those work. Okay. So another one here is ringback. So we talked about ringback, and we said that when I send an invite, I get my trying back, and I get my ringing back to the far end here. When that ringing comes back, it basically tells the phone to play locally generated ringback tone. And so I do my SDP answer offer. Once I've done that, I'll switch off ringback and cut through my two-way media. What you can get is an environment with a gateway here, where what happens is that I do my invites, I support PRAC here, so what I'm going to send in that 1xx message is some SDP here. And by default, what we will assume, and what most vendors assume, is that when I see SDP information in those 1xx messages, that what you want to do is to cut through two-way media, and it's actually this gateway or the system at the far end is going to play the ringing tone back to that end user over that media path. So we assume that to be the case. And so what you can get is situations where you see that SDP in a 1xx message, but they aren't cutting through the media, and they aren't playing ringing tone over that media path to the phone on the far end. And so if that's the case, what you can do is check this box here, disable early media on 180. And so if you're not getting the media cut through from the far end, and they're not playing ringback, the ringing tone to you from the far end to the phone, you can disable early media, and when we get the ringing message, we'll just play ringback in the phone as we ordinarily should do. So that's something that you might run into. We talked about matching these calls on IP address. So by default, that's typically all that you're going to do. You're going to say, when an inbound call comes in, I'm going to look at the source IP address of that invite, and I'm going to see whether that source IP address matches a configured destination address in one of my trunks. And if it does, then I'll place that call on that inbound trunk and apply all the features on that inbound trunk. There are other things that you can do here. So is reroute incoming request to new trunk based on never, that's IP address. But you can look at the contact header information and the call info information here to reroute calls. So you could have a proxy here, for example, if a call's coming in from a proxy, you could route a call a specific way. We also use it in environments with CVP for call admission control as well. Again, do you need to use that? Maybe not. But again, in that contact header, in that contact header there, what you could be sending is information about the version of call manager that you're using. And you might say, if I've got a system here where I've got multiple call managers coming inbound, then I want to treat a call from a call manager 6.0 inbound call differently and associate it with a different trunk to an inbound call from a 8.0, 9.0, 10.01. And that allows you to do that. Okay, so about 20 minutes left, and we're going to go through large-scale design. So this is really trying to put all of this together. So right now, we've been talking about essentially a single trunk between these two systems, but most people have more than one system. And really what we're looking at here is trying to look at all of those pieces. So again, the key things that you want to, the key takeaways here are, how are you configuring the trunk in terms of early offer, delayed offer? How are you configuring DTMF? How are you configuring your media resources such as MTPs and transcoders? Those are your kind of primary considerations when you're looking at all of this. The media resources, because you want to minimize those. You don't want to use those if you don't have to. And then the delayed offer, early offer, if you can have that more or less the same, it just simplifies the configuration and also simplifies troubleshooting across the network itself. So what's typically used is Session Management Edition. So what Session Management Edition can do is actually support up to 2,000 trunks by default. We do have customers with 4,500 is the maximum we've got on a Session Management Edition. But really what you're doing here is aggregating the dial plan into this system here. So you've got a simple SIP trunk, one SIP trunk from each of these devices that points to SME. You could have a default route. I can't find the number here, just route it to SME and it will route the call for me. You can have centralized PSTN. You could have a combination of centralized PSTN and local PSTN. You might be doing tail-end hop-off here, but also centralized conferencing and voicemail systems as well. So it simplifies the dial plan and simplifies how you provide or provision applications such as voicemail and conferencing out to your end users. If you look at how you can deploy this, then back in the day, you would only have the rules for clustering over the WAN for Session Manager were the same as Call Manager, 80 millisecond round trip time between any two nodes. And so if I had clusters all over the globe and I had my SME cluster somewhere in Europe here, then the media path is direct between these two phones if I'm not inserting an MTP resource, but the signaling path is going all the way from the US here down to Brazil. So, if you look at the recommendations for media, it's pretty well defined. We know what that is in terms of over 400 milliseconds, you're going to get bad quality. But for signaling, there isn't no definition. And the reason for that is that it depends on the protocol you're using. But also, if you're using a specific protocol, the number of packets that you'll send to set up media, as we've seen, will depend on whether I'm using delayed offer or early offer or PRAC. And what we'll see is this kind of thing here. So if you've got, this is in Anchorage, Alaska, and this is in Melbourne, Australia, then you've got a long round trip time for these messages going back and forth. And what you can start to see is some delays before you hear ringback tone, because this ringing message takes a long time to get back to you. And again, because I need to go through all of these 5 messages before I can cut through the media, again, I can see this, what you'll see is a clip. So you'll see this a media cut-through delay. So ringing will stop, you'll say hello, you won't hear anything, the media will be cut through, you'll say hello again, and then that person will say hello at the far end. So your first hello will be lost or clipped. And so one of the things that we do here is, as we talked about, is using PRAC. So PRAC reduces the number of messages that we're using across here. But again, what we can also do with SME is to take a single SME cluster and to span that globally. So you can go up to 500 milliseconds round trip time between the publisher and any of the subscribers. I think the maximum we've got, maximum we've got is about 324 milliseconds round trip time. But the nice thing about this means that you can administer this centrally and have now local clusters here. There are some rules that you have to obey so it has to be all SIP trunks to get clustering over the WAN. And again, that comes down to things like the run on all nodes routes. But again, when we talked about media resources, what you don't want to do, so I've got like New York, Los Angeles, Europe over here, and I've got this SME cluster. This could be a pair of subscribers in the US, a pair of subscribers in Europe. What I don't want to do is to start using media resources that are up here on this cluster. So I get a DTMF mismatch or a codec mismatch, and I'm going to insert resources up here. Now, why would I be doing this here? The reason that I would get a resource being used up here is if I had, let's say, an inbound delayed offer here and an outbound early offer on the other side. So what I want to do with this cluster is to keep this as transparent as possible. And that's the consideration that you need to start thinking about, whether you're using SME or not. If you've got multiple legs, if you have one side that's coming in with a delayed offer and one side's going out with an early offer, then you've got a call coming from a system that says, I'm not giving you my IP addresses, I'm not giving you my codecs, but on the outbound trunk of SME, you are required to send the IP address of the device and the codecs that the device supports, but you haven't got them, so you're going to insert an MTP instead. So delayed offer to early offer is really a bad thing to do because you start forcing media resources into the path, and you start hairpinning media in this way. So the way to fix that is and the way to use local media resources only is to use best effort early offer. If you configure the trunks here and here, well, particularly here, as best effort early offer, any calls that pass through this system will be a delayed offer call, will just be passed through as delayed offer, an early offer call goes through as early offer. And so think of the early offer here. So I'm going to send the IP address of this phone, the codecs it supports, how it transports DTMF. It's going to hit this node here on SME. It's just going to forward all of that information on without doing anything. It sends it to the far end here. It's this far end that makes the decision about DTMF, about the codecs that we're using, and so on. And so if there is any mismatch here, I'm going to insert my media resources here. And similarly for delayed offer, I send the invite, and now the offer comes from this end. This guy here makes the decision about what I'm doing. If you have a mismatch here, if this was delayed offer, inbound into here, and early offer outbound, then now I'm making a decision about the media and the setup of that call here, and this is where I'm going to be inserting media resources. So it's one thing to bear in mind. Best effort early offer is the simplest and easiest thing to do, but if you have to go with one or the other, then go with either all early offer or all delayed offer. It will simplify things for you. Okay. Okay. And that's just showing here the media resources being used locally rather than being in Session Manager. Call routing, again, we talked about this idea here of having multiple route lists. So again, I've got my North American SME nodes, my European SME nodes. So from North America, what I want to do is to route my first choice trunk to these two nodes up here. If these two nodes are down, I'm using options ping. I'm going to fail over to this one over here. Again, you've got two trunks in a route list. Run these trunks running on all nodes. Run this route list running on all nodes. And again, the way this will route is that you route here. You're going to make your outbound invite or send your outbound invite from the phone, from the subscriber the phone's registered to. It's going to hit this node, and it's going to go just outbound direct from this node here. You're running the route local rules. So you never route calls in SME. If you're running on all nodes, you're never going to route calls between these nodes here. And that allows us to do this clustering over the WAN up to 500 milliseconds. Okay? Okay. And so just a couple of recommendations here. So this is a bit of a busy chart, but first one on this one is that if you're less than 10.5, you probably shouldn't be. So 9.x went end of support, so you don't get any support from TAC, from Cisco whatsoever for that release. 10.5 is going out of support. I think it's been announced, but it'll go end of support, so no more support whatsoever. I think it's June or July 2022. And a year before that, there'll be no more administrative fixes. We're not going to be doing fixes to bugs in about a year's time. But if you are doing that, there are some considerations here. So I'm going to skip this. You shouldn't be doing it. If you need to, take a look at this. But it really, you need to start looking carefully about how you set all of this up. For SME, you shouldn't really be on 8.5 or above. You should be on 10.5 at least. But you may have older clusters here, and there may be some considerations for those older clusters about how you configure this trunk. So you have mostly older phones, do delayed offer. Mostly newer phones, do early offer, insert MTP if needed. Where you want to get to is this. And this is nice and simple. Everywhere is best effort early offer. From gateways, we always send early offer. If you're going outbound to the PSTN, then if this is an older phone and it sends delayed offer here, I'm just going to pass that delayed offer through up to Cube. You'll do delayed offer to early offer in Cube so that the service provider gets the early offer that they require. Again, what do we need here? So early offer, run on all nodes, multiple destination addresses, options ping, PRAC, and DTMF no preference. So it's pretty much the same across the board. Again, in the SME cluster up here, you don't need any media resources. There's no music on hold server. There's no VMS service. There's no MTPs. There's no MTPs activated. You can disable the MTPs. There's no conferencing resources. Nothing on the call managers, and there are no MTPs associated with the trunks in iOS either. All of that's done down here in the end system. Okay. Okay, and so let's look at caller mission control briefly. So again, if I've got multiple systems down here connecting to Session Manager, what I might have here is this could be the UK cluster, for example, and I could have 15 or 20 branches in the UK. I'll place each of those branches into a location, and I'll count calls in and out of those branches. On these trunks here, you're not going to put these trunks into a location. So typically the trunk from the call manager up to SME is going to be in a shadow or phantom location, because I'm not counting calls over this. This is like over an MPLS connection. It's not like I've got one WAN link here. And really what I'm doing here is I would be using something like a shadow or phantom location. As I make a call between one site here, so branch 1 cluster 1 to branch 1 cluster 2, I'll route the call out of the location here. I'll clock the bandwidth out of the location. But when I go over the trunk here, I'm not counting bandwidth, but I am sending location information over that trunk through SME to the far end here. So this system's actually aware of the fact that I'm making a call from location B to location F. And so now if I transfer the call back to a phone here in branch 1, what we'll see here is that the signaling path is going to be hairpinned back this way. But what you'll know is that you're sending this call back to location B. So this call manager cluster knows that this is a self-referred call. And so rather than keeping the bandwidth up, so 2 call legs up here, so 80K and 80K for 2 G711 legs, it knows it's going back into the same site. And likewise here, it's going to just relinquish that bandwidth, send it back into the pool that you can use. So that's with standard locations CAC. You can also use enhanced locations CAC. Again, a bit busy here, but the key points here is that with enhanced locations CAC, you can share topology information across all of the clusters. And again, the key things that you get here is the fact that you can define the topology information and the bandwidth into and out of those locations centrally, replicate it across all of the other sites. So all you need to do is configure or assign locations to devices. But note here is that I've got a device from this cluster in location D and a device from this cluster in location D as well. And the environment that you might have that would be if you had a contact center cluster and a call manager cluster in the same physical location, they can both use the same bandwidth pool rather than setting up 2 bandwidth pools in 2 separate clusters. You can share that bandwidth between both of them. Okay. For dial plan, there are many sessions on dial plan, so I'm just going to summarize here and talk about the differences with SME. The main pieces here are the fact that in the SME cluster, what you need to have in the SME cluster is a globally unique dial plan. So you can't have overlaps. So you have overlapping dial plan in these clusters over here. You have to normalize them here, and this has to be globally unique. There are multiple ways that you can do this. So when we talk about dial plan, I've got an E164 dial plan in SME here, but you can see that my numbers on my DNs here are 7 digits. I'm doing 8-digit dialing. So there are a number of considerations that you're thinking about here. You can normalize outbound on the trunk and normalize inbound and outbound on the cluster. If you have PBXs, you can do all of that normalization or translation of numbers in the SME cluster. But the recommendation is to use E164 or plus E164 everywhere. That's been recommended now for at least 4 years. And that's really the way to go and the way to do it. If you're looking at large-scale designs, then you may not look at just routing numbers. You might be looking at routing numbers and URIs. In that case, you'll be using ILS for URIs. The way that works is that it greatly simplifies the way that you route calls. So you've got your cluster here. I've got a whole bunch of URIs. These yellow lines are not SIP trunks. Those are the ILS connections that are sharing information between the clusters here. And essentially what I do is I'll register all of my URIs, I'll put them into an envelope, I'll label that envelope, and I'll exchange that information with other clusters. So each of these clusters that's participating in ILS will get information about where the URIs exist and how to route calls there. And so likewise for London, I'm going to do the same here. And if you notice I'm speaking a bit more quickly, it's because I've got 6 minutes left. I'm trying to get through this as quick as I can. So we'll exchange the information. Now when you make a call, so you can import flat files. If you've got a Microsoft system, you can import those into the system as well. And again, the way that that operates is I'm going to, Diane's going to call Helen over here in London. I look to see if it's locally registered. It's not. So what I'll do is then look into ILS. Can I find the URI in ILS? Yes, I can. And then I'm going to refer back to the system and say, use this route string. And the route string basically represents all of the URIs in this cluster down here. So I'm going to send that back to the end system. And then you're going to look for a match on london.uk.eu or something similar to that up here in the SIP route patterns. If they match, what I'll do is just route that over my selected trunk. It'll go up to SME. I'll go for the same process and route that forward. So it's a nice way of setting up URI dialing. You don't have to fragment your domains and say, when you call somebody, it's bob@uk.cisco.com, jane@us.cisco.com. You can have cisco.com everywhere. That also works in 10 for numbers, and this has really become quite popular. So again, it's a separate session on this, so I'm going to whiz through this pretty quickly. It's the same process here, but now rather than just doing URIs, we're also doing numbers as well. And so we can do enterprise alternate numbers, so your 7 or 8-digit number. We can modify the directory number. You can also send the corresponding E164 number for that DN as well, and you can also do patterns. So I'm going to whiz through these slides a little bit quickly. The main points here are that you can do individual numbers, but if you have a very large system, you need to have considerations about the amount of memory that you're taking up in the system. These numbers go into active memory. They're not going into the disk. They're going to active memory in the dial plan storage. So if you have 100,000 numbers in your system, you probably don't want to be advertising individual numbers in E164. You're better to advertise patterns instead. I'm going to skip through this quickly. And again, this is the way you can modify the numbers in a DN. You can take the DN, apply a mask to it. You can put that into your local partitions, choose to advertise that locally. Take the same DN, apply a mask to that, expand it out to the E164 number, advertise that globally, advertise it internally with your cluster as well, and also advertise URIs. You can do patterns. So for large scale, we recommend patterns. But the key thing here with GDPR and numbers, because we used to have SAF before, we still have SAF, but we've probably got about 1 customer using it, is that this allows you to differentiate these number types. So your enterprise alternate numbers, those 7-digit numbers, you could put into one partition. Your E164 numbers, you might put into another partition, and your patterns into others. And what it means you can do is that you can, based on the numbers that you've received, you know how they're categorized. You can say, I know that these are internal numbers, and I'm going to allow this user to make internal calls over the IP WAN, but when they receive, or when the cluster receives the PSTN numbers, for this particular user, I'm going to allow them, I'm going to place that partition into the calling search space for that user so they can do tail-end hop-off, but for another user, let's say in India, they can't do that. Okay. And just a final one here, this also works in Cube, by the way, as well, so you can use GDPR and ILS in Cube as well. And the final one, I think this is about as far as I'm going to get, so it's pretty much most of it, is like, what do I do here? I could do GDPR or SME or both. And so if I'm doing GDPR only, what you have to have is this full mesh of trunks between all of them. The dotted line is ILS. I've got Toronto as my hub here, and these are the spokes. But what you get here is that each of these clusters has to have six trunks configured on them. So it's overhead in terms of configuring the trunks. If I'm just using SME only, you've got one trunk outbound, but actually just go back here. I've got this, but what I have here is a single route pattern that represents, so in each cluster I have a single route pattern, or 6 route patterns, so 1 route pattern for each of these remote clusters, any of the number ranges and any of the URIs. With SME, I get a single trunk, but now I need to have multiple route patterns here. It can get pretty complex in the SME cluster. And so what most people do is combine both of them. And so what we see over and over again these days, this is a typical design where I've got, you can typically have up to 10 or 11 spoke devices here in ILS, SME being the hub. You can go beyond that, but 10 or 11 is typical the number. You could have multiple hubs as well, but now what I'm doing is I've got the best of both worlds, a single trunk from the leaf cluster up to SME, and now I've got a single route pattern. I've got the default route in each of these that says, to get anywhere, go up here, and once I'm up here, this SME would have 1, 2, 3, 4, 5, 6 route patterns that would represent every number and every URI in your system. If you think about an SME without this, you could have thousands of them, and we've tested up to 50,000 route patterns and translation patterns. With this, you have a single route pattern for each destination cluster that you're going to, okay? And the last few here, really quickly. So applications, you can have multiple types. The key point here is that if you've got applications that need to track user state, they need to be located with the leaf cluster, so IMP, an operator console with BLF, contact center, emergency responder. What you have up here are number-based systems, so voicemail, meeting server, PSTN. 1 minute. So this is pretty straightforward. And then the last one here is for Expressway. So the only thing I want to note here is that you could be using Expressway for 2 things. For B2B calls, I'm running a call over a trunk here. If I'm calling to Ford.com, I run it up to SME and then out through C&E, out to the outside world. For MRA, it's line side. So for MRA, you're going to log in, you'll look at your username, find out where your home cluster is, and then extend your line side connection down to that destination cluster down there. Okay, I got to the end with no minutes to spare. So I'll take questions afterwards if you want to. Please provide feedback. But thanks for staying with me this morning. I know it's a lot to take in. Use the slides as reference. There's a load of stuff in the appendix there if you need it. And again, the space is open. The PDFs of these slides are in the space. If you have questions, drop them into the space, and I'll come back to you. Okay? Thanks, Carly.